Hey hackers, I'm Ford, an engineer at Edge and Node, and I'm going to be giving a workshop today on creating, deploying, and using subgraphs on the Graph protocol. This workshop is going to be directed towards new users of the graph, so if you're a seasoned subgraph veteran, this will most likely be review for you. Before we get into the workshop, just a reminder that we will be giving 2 prizes in this hackathon, one for the best use of an existing subgraph from our sponsors, and that will be awarded 1,500 DAI prize, and another prize of 500 DAI will be rewarded to the best new subgraph deployed to the Graph Explorer. You can find a list of the sponsored subgraphs on the website. Okay, let's get into it. So what is a subgraph? A subgraph is a definition of data that you would like extracted from an Ethereum chain and a corresponding definition of mappings that transform that data into a structured data set that you can then query via an open GraphQL API. Now, that's a bit of a mouthful, so let's go into it to learn by doing. So in order to do that, I'm going to be deploying a simple NFT tracking subgraph today. So we are going to find a contract that follows the ERC 721 token standard. And then we are going to create a subgraph to track that token. To keep it simple today, I think we'll just track the transfers of that token and the holders of it. So before I get started creating and deploying a subgraph, I need to make sure that I have the necessary prerequisites installed on my computer. I need to have Node installed and a Node package manager such as npm or yarn. And then I also need to install Graph CLI, which is our CLI for creating and deploying subgraphs. So I'm going to switch to sharing my screen and we can work through this together. So I'm going to go to my workspace and make sure that I have Graph CLI installed globally on my computer. And while that is installing, I'm going to start doing a little bit of research. So we're going to need to figure out what the contract address is for the token that we're going to track. So today, I'm going to track the Zora token, which extends the ERC 721 standard. So let's go find out where that contract is deployed to, what the contract address is. I'm going to go to the Zora documentation website at zora.engineering. And let's see if we can find the contract address. So here we have the mainnet media contract address. And let's go check it out. Okay, this looks like the Zora token. All right, we're going to grab that, put it in our clipboard here. And now what I'm going to do is I'm going to use the Graph CLI to initialize my subgraph project. So I'm going to make sure I'm in the workspace that I want to be in. So I have a subgraph folders here. And then let's check out the graph init command. So you can see that with graph init, I can either initialize a subgraph from the example, or I can do so from a contract. Today, I know what contract I want to track, so let's go ahead and initialize it from a contract. So to do that, I'm going to do graph init from contract. And everybody have it stored in here. So that's my Zora contract. We're going to initialize it on mainnet network, and we're going to tell it to index events. So that will automatically initialize the subgraph that is tracking all events emitted by the contract. I'm going to name that contract just token here and name my subgraph forward end Zora token. All right, let's go. So it's going to prompt me to confirm all of my entries here, the subgraph name, the directory I'm storing it in, and the network. Okay, and then the contract address, confirming. And you can see here that it has fetched the ABI from Etherscan. Okay, so it's initializing the subgraph and installing all necessary dependencies. And while it's doing that, I'm just going to go over to my Etherscan page and confirm here that the source code is there, as well as the ABI. So the initialization should have no problem picking up the ABI that we need. Okay, so it's finished initializing. And so let's go ahead and open up that project in our IDE. And so we can take a look at what it's initialized for us. Okay, so here we are. We have a full project created for us. We have the ABIs, we have mappings, and we have a schema and a subgraph manifest. And you can see that the schema here is already populated with 5 different entities corresponding to the events emitted from that contract. It did this because we supplied the contract events parameter on initialization. Okay, so it's currently tracking all events, and it's simply converting the parameters of that event into the entity and saving it directly. This is a really nice start and gives a good example of how mappings work, but it's not necessarily going to be a very useful subgraph. So today, let's update this so that we can track users that hold the token and transfers of that token. To do so, let's start by updating the schema. So instead of just having these entities for each event, let's create some new entities. So we're going to make a token entity, and that's going to have an ID, which is a required field on all entities, and a token ID, a content URI, which will have the location of that NFT content, and it's going to have a creator address and an owner of whoever currently owns that NFT. And then let's create another entity here called user, and that is going to track the creators and holders of that token. So again, we need the ID, and then we are going to store the tokens that user holds and the tokens it has created. And so this is a good example of how we store relationships in the schema. This is a virtual relationship, so the data is not stored in the database. It is joined at query time between these entities. And here I'm going to define this derived from directive, and specify the field owner. So that array will be populated based on the owner field in the token entity. In order for this to work, I'm going to have to update that owner field to be user. So this is a two-way relationship here. I'm going to do something very similar for the created field. Okay, so let's get rid of all these auto-generated entities, and we now just have our simplified schema here. And so the next step here is going to be to run CodeGen, and that will generate our TypeScript classes from this schema. Those classes will provide functionality for creating, saving, loading, and updating the entities. So to run CodeGen, I'm going to run graph CodeGen here. And we'll see here that the generated entities have changed. So we now have a token class and we have a user class. So now that we have those classes, let's go ahead and create some mappings to save data into those entities. Let's go ahead and get rid of the existing mappings here. The only ones that we are going to keep are the handle token URI updated and the handle transfer. And that'll be sufficient for tracking the transfers and the holders of the token. Okay, so we're going to update this import to have our new entity classes, token and user. And then let's go ahead and update this handle transfer function to track what we need. So before we get into this, I'm just going to lay out our goals here. So what we want to do is we want to check if the transfer is mint or a transfer to a new owner. And then we want to, if it is a mint, we're going to create a new entity. Otherwise, simply update the entity owner field. In addition, we want to check if it is owned by an existing user. And if not, then create a new user. Another thing we're going to do here is call the contract to get the content URI, because that will not be in the transfer event. Okay, so let's get started. So what we're going to do is we're going to load the token, and if it exists, it'll load that token. Otherwise, we'll get a null value and we'll be able to check that. So let's use the token ID in string format to attempt to load that token. And then let's check if that token exists already. And if it doesn't, we're going to create a new one. And we're going to initialize it with a creator and a token ID fields. So if it's a new token, the to field will contain the creator address. Cool. And now we're also going to, regardless of if it's a new token or if it's just a transfer, we're going to want to update the owner field. And then save the token to the database. Okay, so now here we've checked if the token exists, and if not, we've created a new one. And then we update the owner field in either case. Cool, so that was our first step. Now the next is to check if it is owned by an existing user, and if not, then we're gonna create a new user. So this is a similar process. Let's attempt to load the user. And then if user equals null, we're gonna make a new one. And we're gonna save that. Okay, so we are almost done with our plan here, but the last thing we want to do is save the content URI. The content URI is not emitted from that event, so we're going to have to call the contract to get it. To do that, we will bind to the contract. Let's make sure we have that here. Okay. Binding to the contract with the address of that event. So this will bind to that contract at that block number, and then we can make contract calls as of that block. And we're going to call the token URI function to get the URI of that token. Okay, that's looking good here. Great. Okay, once we are done with that, I'm satisfied that these to-do lists have been completed, so I'm going to get that out of there to clean it up. And now we're going to move on to the handle token URI updated function. This one's going to be pretty simple. We're just going to load the token and update its content URI. So you can see that URI field was emitted on the event, and we are going to add that to the token we've loaded and then save it back to the database. Okay, so now our mappings are doing what we want them to do. We have a schema with a token and user entities. Let's go look at the manifest here. So let's update the entities referenced in the manifest. Let's update the event handlers so it's not calling these non-existent handlers. So we only have token URI updated and transfer. And then in order to make it as efficient as we can, let's add a start block here. What this will do is it'll only start syncing that subgraph as of this block, and it'll avoid the work of looking through the blockchain before that block. We can go back over here to the contract and look for the contract creation transaction. And we can see that that was at block 11,565,020. And so we will use that as a start block, and that'll save us some time syncing the subgraph. All right, now that we have our mappings and our schema and we've updated our manifest to our liking, let's go ahead and build our subgraph. Great, that built successfully. Okay, so we're going to navigate to the Graph Explorer now. And we're going to create a subgraph on the Explorer, and then we'll deploy our newly created subgraph there. All right, I'm already logged in. I'm going to go to my dashboard, and I'm going to add a subgraph here. I'm going to call it Zora. Provide a quick description here and create that subgraph. Okay, so let's see, here we have that subgraph is created, and now what we need to do is deploy our local subgraph to that newly created subgraph on the Explorer. So I'm going to copy my access token here, and I'm going to go back over to my terminal in my subgraph project, and I'm going to go ahead and deploy it. So I'm going to use the saved script for deploying and supply my access token, and we'll go ahead and deploy. So it has built our subgraph, it is uploading it to IPFS, and it's sent the deploy command to the Graph Explorer hosted service. Okay, looks like that's deployed. All right, we're syncing. We already have 7 entities. We can supply some queries here, and we can see that we're getting tokens coming in with content URIs and creator IDs. Great, that didn't take us too long. Let's make sure these are working as we'd expect. So I'm going to just go ahead and take that content URI and open it in the browser here. That wasn't so interesting, so let's try this other one here. Okay, okay. So it's got an image. It's not the most interesting image, but I think we can get a more interesting example here going. Okay, so we've gone through the process of initializing a subgraph, creating it to get the data that we are interested in, and deploying it. And we can see that we can try out queries in the playground. So this is a great first step. Let's now go over to some existing subgraphs And let's go through some examples of how to query those subgraphs for data that we're interested in. And so we've been looking at the Zora subgraph so far. So let's switch over and look at the foundation subgraph. So I'm going to go ahead and navigate to that. All right, here's that foundation subgraph. You can see here again, we have the query playground. And on the right side, we have the schema. And you can see that they've added some nice comments in the schema to explain how each field relates to the other and what data is stored there. This is a great place to get started looking at subgraphs. By looking at the schema, you can get a good understanding of the data structure and then dive deeper from there. So let's see if we can answer some general questions of this foundation data. Let's see maybe who are the top creators in the foundation network based on net sales. So to do this, I'm going to query the creator entity here, and I'm going to add some filters to it so we can sort it by the sales of each creator. So let's see, we have in this example query, we can modify it a bit. For each creator, let's go ahead and get the ID, net sales, net revenue in ETH, net pending sales, net pending revenue. And then let's also look at what NFTs are associated with that creator. Get the token ID, the IPFS path, so we can view that NFT, the name, image, and then for that specific NFT, we can also get revenue and sales values. Okay, that could be interesting, but let's take it a little further and let's add an order by here. And order by the net revenue in ETH. Make sure that that is ordering it in descending direction. And then let's get the first 10. So that'll give us our top 10 creators. And let's see what we get here. Cool, so we have an array of creators returned. And with the data populated that we want. Okay, we can see the image and name don't seem to be used here. But we are getting the token IPFS path. Very cool. So we can go a step further and actually view those tokens. So let's take that IPFS path and see if we can take a look at it. Let's see, ipfs.io, IPFS, and we're gonna paste that path in there. And that gives us a name. So that's called finite with a simple description and an IPFS link to the image. Cool, so let's go check out that image. Hey, there you go. Okay, that's a cool NFT. So you can see how pretty quickly I can query NFTs here. I can query creators, and I can actually pull up the actual images or videos associated with that NFT. So using these queries and the query API, HTTP API that's shared, you can see how you could easily integrate this into a front-end app that is able to sort by creators and display their art. Okay, so we've quickly gone through the creation of subgraphs, and we've gone through how to query subgraphs in order to get useful data. And then the next step might be to integrate that into a front-end application, which we will not have time for today, unfortunately. I hope this workshop has been helpful to you in giving you a quick overview of how subgraphs work and hopefully provide some inspiration that you can take forward into the hackathon. All right. Happy hacking, everyone. See you later.